All right, I think it's time, so we'll get started. It's an undeniable truth that data is growing, right? And data is not, it never sleeps, as we know it. In the next 1 minute, before I go to my outline slide, you will see that 66,000 images will be uploaded in Instagram. There'll be 5 million Google searches. There'll be 500,000 worth of Amazon transaction or Venmo transactions. Where is this data going? It needs to stay somewhere, analyze somewhere, and processed, and decisions need to be taken. On the other side of the spectrum, you can see in rural America, you'll see the the weed spreader, the spray that sprays on the weeds. Those tractors are collecting enormous amount of data and analyzing it with the library of 1 million images real time and making decisions which weed to spray on, right? All this data, the growth of the data is real. It needs to go somewhere. It needs to be analyzed. And it is across the board from core to the edge. My name is Tahmid Rahman. I'm from Solidigm. Solidigm is basically what we do is, if I summarize it, it's a SSD company. And we are the storage advocate for you guys. So that challenge that I talked about, the growth of the data, where does it go, where does it reside, how does it get analyzed? We're going to be touching some of these aspects today in this talk. So let's just talk about some of the outlines that you'll see in this very short period of talk from me. One is the changing landscape, core to edge challenges, and how we are equipped with that. I'm going to talk about some of our portfolio, which is based on hyper-dense storage that is at the core of providing value, not only to the core, but also to the edge and the endpoints. And then I'm going to wrap it up with some collaboration efforts that we are doing with the industry, some of the innovations that we are doing along with OCP. OCP is inspiring us, and we are also feeding back to the community through customer engagement and cross-customer discussion and industry co-traveler discussions. So I'm going to sum it up there. So before I go there, where do we stand now? We stand in a place where there's a lot of data that is being consumed and analyzed at the core data center, right, as you know. And as you can imagine, 85 to 90% of the data is still HDD based. So legacy architecture, performance challenged, density challenged. So that is the reality right now. But at the same time, data is growing. SSD CAGR is higher than the HDD CAGR. As we see new entrants in the market in the form of artificial intelligence, AI, machine learning, edgification of the data, we can see that this data is also growing, and it's actually going to different places. It's going to the endpoints. It's touching the edge. As I talked about the smart tractor, that is touching a lot of lives across the board. So that data is being driven by a few of these growth, I would say growth metrics. Like, for example, AI workloads, AI models are growing 10x every 2 years. There is a prediction that we will be having 10 billion connected devices by 2030. That means these connected devices will actually increase by 3x by 2030. So all these growth vectors are driving the proliferation of the data and the growth of data, and that needs to go, as I said, to the edge and the edge point. But not always these data need to be moved back to the core, because if you think about it from a cost point of view, bandwidth point of view, this is going to be cost prohibitive to basically push everything to the core, number one. I mean, in some studies, they're saying 4x more costly than storing the data. Secondly, the latency and the service level agreement that you have at the edge going to be more strict than moving data around in a central location and basically analyzing it. Think about of the order of 10 milliseconds versus 100 milliseconds of difference. So all these are going to that discussion point that I'm going to talk about is the hyper-dense storage, which will be probably coming to the rescue of all of it. And before I go there, Maybe I spend a little bit of time on one of these, use cases, which is smart transportation, or you can call it connected car. People call it ADS, be it in a vehicle that is, in use or in development. You see a tremendous amount of data growth. By 2030, you'll see 95% of connected car on our roads, right? What does it mean? The cars you and I drive, they have their number of sensors that they have is going to grow tremendously. It's a 2x growth over next 5 years. And these sensors are creating enormous amount of data as well. The data rate, the ingest rate is really high. So when I talk about hyper-dense storage, I cannot only talk about the density, I also want to talk about the high-performance drives, because these applications will require a lot of ingest rate. Like, for example, in our use case, in one of the ADAS customers that we had, first Mobileye and then Innonet, we saw ranging between 30 terabyte to 320 terabyte on a particular vehicle. And they are doing up to 28 gigabyte per second of ingest on these devices. And by the way, they are using QLC, the ones that I'll be talking about. As this data gets generated at the edge, these data are pretty rich. They're not periodic data, or they're not snapshots. They're basically the full trip loads. And that needs to be uploaded at some point. Maybe 50 to 70% of the data needs to go somewhere. And that's where the edge infrastructure comes into place. You guys have probably saw AWS Snowball or Snowmobile or Snowcone. Those are perfect examples of edge infrastructure where data can be actually mobile, up to 80 terabytes in this case, I'm saying. And then last but not least, on the core data center is predominantly based on HDD, up to 240 terabyte per server. These also will actually go through an evolution, right? Because as the data data grows, and as there's need for performance, you need to be thinking about replacing some of these HDDs. Per server density has already gone up at the CSP level, but we see that in near future that'll also go up to like a petabyte range. If you go back to our our booth out there at A8, you'll see that we are showing more than a 1 petabyte density in one server. So again, this is just one example, and this example can be expanded to a CDN workload, can be expanded to a security surveillance workload. It can be expanded to medical and other areas where this rich data set being created and generated every day, every minute. So what are those challenges that we are facing right now? So the challenges are common challenges, if you ask me, between the core and the edge. The challenge is about the size and the weight, right? Again, I mean, it is easy to do a multi-storied data center for core. But when you're talking about a remote location, your size and your weight limit is there. We call it the locality challenge. There is power limitation, right? So at the edge, there may be, those power limitations may be battery dominated. And you may be thinking about different form factors than what your traditional core data center is using. Last but not least, the serviceability. It is not always practical to roll in a truck and do a debug on a drive, right, which is sitting in a remote location. Secondly, the reliability and the operational excellence, those are pretty, high standard in the core data center. But as you move to the edge, those requirements become more and more stringent because of the ruggedness, the harsh environment that they're subjected to. So all these are challenges, and that's why we are here in OCP. We want to solve those challenges with you guys, and how those hyper-dense storage can come to the rescue is the next part of my discussion. So when I was there, the stage was over there last year, and we talked about, hey, we're going to be bringing some cool drives in the market, right? 61 terabyte. So I'm very pleased to say that this month, our 61.44 terabyte drive has gone into high volume manufacturing production. So they're widely available right now. There are two swim lanes of product that I'm actually introducing here. One is the P5430, which is a replacement for TLC drives. It can go up to 30 terabyte. So you don't have to worry about, indirection units and stuff like that. And then there's another variant of the product, is P5336, which is going up to like 61.44 terabyte. You may ask me like, hey, why are you guys so bullish about QLC? I think I want to summarize. I don't have too much time, but I want to summarize it in two ways. One is, it is much efficient and sustainable to go to those high density SSD at a system level, designed with those SSDs, which is QLC based, because you get the bit density. Number two, the modern day QLC drives are made for the workloads that is emerging, read intensive workload, right? A lot of sequential streams, right? Think about the images that's coming in, the CDN workload. So all these things are making us make the right choice on the roadmap that, hey, these drives will probably be the building block for those AI, ML applications that requires density. There will be applications that does not require density. So not going to talk about it, but hyperdense storage will come a long way when it comes to accelerating access to data like never before, and in much more different places. So I'm going to actually switch gear and talk about some of the solutions that you can see in the market, right? Over here, we're showing a Dell XR12 server, right? And that server is housing 6 SATA SSDs. And this is a purpose-built, rugged server that you can actually subject to endpoints and edge server type of situation. You can actually replace that with one of these U.2s, right? And each of these can go up to 61.44 terabyte. You're seeing tremendous amount of density packing in the server. Not only that, your performance is better. Your operational efficiency, which is much important. I mean, you talked about in the keynote, performance density, density per watt, power density. On all these metric, if you replace that with a high density QLC 61.44 terabyte, you get those benefits. Not to mention the endurance. Endurance is basically given that QLC endurance is ample enough for most of this workload. Second example that I want to put over here is a legacy HDD-based design. This houses actually how many SSDs here? I think, let's say you have 8 SSDs, right? 8 HDD, 4 HDDs. So 4 HDDs, you can actually replace it with the E3.S new form factor up to 30 terabyte. Again, the story remains the same. Really good power efficiency, density per unit, and at the same time, endurance is also not a factor here. Operational efficiency much higher. And then last but not least, a system that is at the end point. Think about a telco tower where you are maybe housing a small server with 8 M.2s, right? That's a legacy design. And M.2 as a connector has some limitation. So if you go with a modern design of, I'm holding a partner's drive here, SK Hynix, but we also have P5430 E1.S, and those are really, really high density, 15.36 terabyte. Replacing them with 8 of those, right? Again, you get the density, intensity that you are looking for. At the same time, you're getting the operational efficiency and sustainability aspects in terms of endurance and reliability. So overall, what we are trying to show here is between the U.2, E1.S, and E3.S, right? All these form factors, we have it in the couple of swim lanes that I talked about, the QLC swim lanes. So we are really equipped to go and make this happen. We are right now at the very front, at the first level of the AI evolution, and from a storage point of view, I think these are great examples of accelerating workloads with the QLC SSDs. The other thing that I want to talk about is the monitoring, security, and manageability aspects of these SSDs. As they get deployed at the edge, you want to make sure that you have remote monitoring capability in the devices. From the very beginning of NVMe, monitoring was a big part of SSDs. So now is the time to extend it to the edge. The security aspects, we started with the drive at rest encryption security features. Now we are thinking about, instead of just doing the drive locking, how can you do the namespace locking? How can you do the I/O locking, keeper I/O for future? We're looking into attestation of devices remotely so that these devices can be used for better inventory management and whatnot. Last but not least, manageability. You have really high density SSDs, you want to monetize them, you want to partition them in namespaces, you want to use power governor to regulate power on them, and then basically, last but not least, thermal throttle and device self-test. These are all part of the SSD offering. It's a matter of using them for the right application at the edge, and how do you take advantage of it. And for future, we're looking into like flexible data placement mode where you can actually extract much more, drive life out of these devices, because that will be a key thing for future at the edge, reuse, repurpose, and extend the effective life of the SSDs. Last but not least, I just want to highlight that, hey, we are here. We've been innovating in multiple areas. Come to our session tomorrow on sustainability. I talked about thermal methodology here. So we've been working with the customers and providing you guys guidance on thermal. We're providing you immersion cooling and liquid cooling, which has become not only a nice to have, but trending to be an essential component of future data center, also for the edge. So we are doing a lot of POCs in that area. Form factor, I already covered that we're innovating across different form factors, across different QLC, SLC, and TLC, and then reliability and endurance. I just talked to you about a 0.5 drivers per day QLC product, which is good enough for a lot of AI applications, but we do have a full portfolio all the way from 50 drivers per day to 0.5 drivers per day. So any of these devices can be, if there is more caching going on in some applications, you may take advantage of those high endurance devices. And then one thing to make sure here that the QLC devices are giving you up to 210 petabytes written endurance, which is the highest in the whole family of products that we offer between SLC, TLC, and QLC. So endurance should not be a factor here. And last but not least, the core of it is density. So our density, our NAND density is 28% higher than the alternative. We are, as you have seen, we are completely committed to giving you the hyper-dense storage at multiple form factors, which is performant, which has the performance density, the power density, and has the right workload acceleration for your applications. So as we say, density rules, as just AI rules and data center growth rules, but from our point of view, we want to be a part of this journey with our density story of hyperdense storage and highly performance and power optimized storage solution for the next generation data center, not only at the core, but also at the edge and the edge endpoints. Thank you for listening to me. I'll be around, so if you have any question, I'll be happy to answer. Thanks.